Hello, this is Dr. Keith Schubert, and this is the third and final example for integer division on or on a MIP system. So, as in previous videos, video one kind of covered the theory and also had an example. The second one was just an example. This one will also just be an example. So in this case, I decided to pick one we always had before there was a remainder. In this case, I'm going to get one that doesn't have a remainder. Plus, this one will just have us doing an awful lot of setting bits inside the divisor. So we're going to do 15 divided by 1. 15 is, of course, all ones, so we put that in the quotient. The high bit is always set to zeros, and the divisor in this case is 1. So that is our problem setup. First thing we do is shift left logical, so the leading bit here comes over, all the other ones shift. And our first guess for the quotient bit is 0, which of course is going to be wrong, but shift left logical always puts a 0 in, so it's a good first guess. It doesn't involve any extra work. We subtract 1, so what you subtract from is 0, 0, 0, 1 minus 1 gives me 0. Again, you could actually do this, technically speaking, with just doing the 2's complement of this and adding it to it. So we're technically taking 1, 1, 1, 1, that's 2's complement of the divisor, and adding it. But note, if you add 0, 0, 0, 1 to 1, 1, 1, 1, you get the overflow, you get 0, and then a carry 1, and the carry just ripples all the way down, setting all these bits to 0. So just as a note, you can also actually explicitly calculate this, but in this case I'm just doing it simple. I think it's easy enough to just see 1 minus 1 gives you 0. But realize that would actually be handled by 2's complements inside the hardware. Alright, since it is greater than or equal to 0, 0 being greater than or equal to 0, we set the least significant bit. It should have been a 1. Now this down here, that 1 is actually the first bit of the quotient. Alright, so now we shift left logical the whole thing. The 1 comes over. All 3 of the remaining bits shift. A 0 comes in as the second guess of the quotient. So right now we've got this, which is the first 2 bits of the quotient. Technically speaking, this is actually part of the remainder as it's moving over, because these are bits that will eventually shift in. This bit at the next stage and that one at the final stage. But really you're kind of watching this kind of jagged edge of, here is the remainder kind of carrying the whole thing, and then quotient starts moving over slowly but steady. Now we see we've got a 1 in there again. 1 minus 1 gives us 0. And that tells us that indeed it was greater than or equal to 0, so we have to set that least significant bit. So now we have our 2 most significant bits of our quotient are 1, 1. Our next set of 3 shifts over, the 1 comes in. Now we've got 3 bits of our quotient in. 2 we've calculated, and the guess at step 3, which is 0. We do the subtraction. 1 minus 1 gives me 0, which we can then see is greater than or equal to 0, so we leave it alone, and we set the least significant bit. So now we have seen, of these 4 bits, 3 of them are for the quotient, and they are now all correctly 1, 1, 1. Shifted over, the final remainder bit moves out. We now have, these are all quotient bits, the final one just being our guess. 1 minus 1 gives us 0, and so indeed, that being greater than or equal to 0, we set the last bit. So we find out that 15 divided by 1 is 15 with no remainder. Now, one of the reasons why I kind of like this one, if you look at it, It's actually exactly the same at every stage that's going in. Because it's division by 1, it's kind of easy. You're just shifting the number back in. But I do think it is kind of neat to see how it actually works and shifts on down. So at this point, you've now seen 3 examples of it in practice. Hopefully it makes sense to you. If not, please drop by my office and we can work through and make sure that you understand this before we have to deal with this on homeworks and tests and stuff. So hopefully everything's good with you on how to handle integer division, and I will see you on Monday.